simplifying expressions involving exponents. So lesson 1 and 2 are going to be that stuff where I call that brain exercise. There really isn't much application to it in these 2 lessons. So we're doing sort of all of that groundwork, all of that skill work that we're going to be able to apply these exponent rules to later on. So yes, it's just exercise for your brain, but it's really important that you have these exponent rules down by the end of this unit, okay? Because we will use them constantly. It says there's many situations in science and engineering and other fields where we use that repeated multiplying, or dividing for that matter, by the same quantity. So repeated multiplication or division, that shortcut is to use exponents. So if we take this first question here, 6 to the third, and write it as an extended product, but it says do not evaluate. So 6 to the third means 6 times itself 3 times. So if we were to take this function, f of x equals 2x to the third plus 7, and they want to evaluate f of negative 1, so we would say that that would be 2 parentheses negative 1, because we're putting that negative 1 in place of the x, plus 7. And now, if we were to evaluate that, obviously, once you've done that substitution, by all means, go right to your calculator. But sit and think for just a moment. Negative 1 to the third power, anytime you have a negative raised to an odd power, it's going to come out to be negative. So really, sort of that intermediate step right now is going to be 2 times negative 1 plus 7, which comes out as your final answer to be 5. So if we take that idea, now we apply it to algebra, x to the third times x to the fifth is written in the form x raised to the n, so some exponent. What is the value of n? Write the extended product if you don't remember the exponent rule. So if I extend this out, x times x is x to the third, and then that's times x to the fifth. Oops, sorry about that. So we have x times itself 5 times, and these are all to the first, okay? When it's not written there, we assume that it's to the first. So what do we end up with? We end up with x to the 8th. So what just happened there is the rule is when you multiply, you add exponents. Okay, so when you multiply, you add exponents with like bases, I should say. Okay? With, that's the key, like bases. Okay, those all had a base of x. Okay? So now it says, if the expression 5x to the third to the second is written in the form ax raised to the b, what is the value of a plus b? So I'm going to take this expression and I'm going to expand it out. So 5x to the third squared means 5x to the third 2 times. So now I can do that multiplication where 5 times 5 is 25. And now I have like bases here, x to the third times x to the third, which means we would have x to the 6th power. Okay, so now it says, what is the value of a plus b? Well, a in my general form is my coefficient, and b in my general form is my exponent. So they're saying, okay, well, what is 25 plus 6? And our final answer is 31. Okay. So now let's talk a little bit of scientific notation. It says if the length of a rectangle is 3 times 10 to the 5th, and the width is 2 times 10 to the 4th, what's the area in scientific notation? So area of a rectangle we know is just length times width. So if we've got 3 times, oops, sorry about that, 3 times 10 to the 5th, just lost my cursor. So 3 times 10 to the 5th, and that would be times 2 times 10 to the 4th. Okay, well, my coefficients are the 3 and the 2. So 3 times 2 is 6 times, and then I have 10 to the 5th and 10 to the 4th. Those are my like bases, so I could add those exponents where I end up with 10 to the 9th. So the area of that is 6 times 10 to the 9th, and they did give us a unit there, and it's meters squared. So let's take and apply it to this one. So it says rewrite the product as an equivalent expression in simplest exponential form. So they want us to evaluate this in the end. I don't know why my cursor just kind of keeps disappearing on me here. I need to restart. I don't know. We'll see. All right, I'm going to pause and restart. Okay, so 3x squared, and that's squared. So that means 3x squared times itself, okay, 2 times. And then 2x to the 5th is raised to the 3rd power. So I would say 2x to the 5th 3 times. Okay. And then multiply those coefficients. What's 3 times 3? Times 2 times 2 times 2. So we get 9 times 2 is 18. 18 times 2 is 36. 36 times 2 is 72. So we did all those coefficients. Now we have all these x's. X to the second, x to the second, okay? And then x to the 5th 3 times. So again, when we have like bases, add those exponents up. So 2 plus 2 is 4, 9, 14, and that gets us to x to the 19th. That would be in simplest exponential form. So we also like to write in simpler equivalent expressions. So it all comes down to our ability to unmultiply fractions, which in other words means divide fractions. So I'm going to change this up a little bit. I'm going to kind of just ignore these directions, and I want you guys just to consider this expression, and we're going to simplify it. Okay, so we're not going to do part A. So if I take this 2x to the 6th divided by 4x to the 2nd, so again, my coefficients are 2 and 4. So what is 2 divided by 4? In other words, simplify that fraction, which we know is 1/2. So if we were to back up here, when we're multiplying like bases, we add the exponents. So what do you think we do when we divide? Exactly, we subtract the exponents. So when you divide like bases, subtract the exponents. So x to the 6th divided by x to the 2nd, that ends up leaving us with x, I'm going to write this out, to the 6 minus 2, which ends up being x to the 4th, all divided by 2. So if you have that question, well, how do you know where that x to the 4th is left? Think about this. There's x to the 6th. There's 6 x's on top, and there's 2 x's on the bottom. So where are more of them left over? They're left over in the numerator in this particular question. So go ahead, flip the page. So again, we're just going to simplify these, okay? We're not going to do this rewriting business. We're just going to write it in a simpler form. So like bases, so really this is 5 to the 7 minus 3, which is 5 to the 4th, okay? Then this one would be x to the 4 minus 10, which is really x to the negative 6, but we haven't really talked a lot about negative exponents, and that's going to come up in the next unit, so, or the next lesson, but let's go there right now. So let's think about this for a second. X to the 4th is that, and x to the 10th, okay, for the sake of time, writing all of those x's out, we'd end up with this. I'm going to put in 4 of them and then extend that out. So why did I just write in 4 of them on the bottom? So what happens? What's x divided by x? It's 1. X divided by x is 1. These divide each other out. What are we left with in the top? We're left with a 1. Not a 1x, a 1. And what essentially are we left in the bottom? I didn't write them all out. We're left with x to the 6th in the bottom. So right now, x to the negative 6 is equivalent to 1 over x to the 6th. And we're going to spend more time with that in the next section. Okay. Okay. So now this one, we've got x's and y's, and remember that that exponent right there with that x in the denominator is x to the first. So like bases. So x to the fourth and x to the first. So we end up with x to the third on top, and y to the eighth divided by y to the 10th. Where are there more where are there more y's right now? There's more y's in the bottom. Well, we're dividing, so you subtract those exponents. What are we left with? We're left with y to the second in the bottom. Or this could be written as x to the third, y to the negative 2. Okay, these two expressions are equivalent. Okay, these two expressions are equivalent. This one usually is preferred when you have all positive exponents. That's usually the preferred method to write your final answer, with all positive exponents, but they are equivalent. Okay, so let's take a look at this one. So this next one, if I were to write this all out, I'd get 3x to the second power 3 times, all over 9x to the fourth. Multiply those coefficients. So that's 27x, 2, 4, 6 of those in the numerator, 9x to the fourth. So now divide those coefficients, and we end up with 3. And then when we're dividing like bases, what do we do with those exponents? We subtract. Where are they left? X to the second. There's more x's in this numerator right now, so it would be x to the second. So technically, what's left in the bottom? There's just 1 left in the bottom. Not a 1x, just a 1. And again, you don't need to write that 1 in the bottom. Okay? All right, I'm going to give you the answer to this one. Play around with it, okay, and see if you can get that. Divided by 4. Okay, that's the final answer on that one. And now it says, the diagram below shows how this expression gets simplified. For each transition, give a rule or property. This is just like those, what we do with equations. So here's the original problem. And then how does this original go to this? It's all expanded out. So that's just our definition of an exponent. Okay, definition of exponents, to expand it out like that. Then how does it go from this to this? So we've got some rewriting going on, okay, and some changing of some groups. So when we change the groups, that's the associative property. Okay. And then when we go from here to here, okay, this is just multiplication, okay, of fractions. We're just multiplying, okay, the multiplicative property. Okay. And then we've got our final answer. Okay. Go ahead, let's go to lesson 2 on 0 and negative exponents. So let's extend this concept to areas that may not make a lot of sense to us. So it says pretty much everyone can understand that 2 to the third, what that means. Okay, it means 2 times itself 3 times. So it says, yet, what does 2 to the 0 mean? Or 2 to the negative 4 mean? Okay, so it says, does it make sense to talk about multiplying by a number a negative amount of times? Okay, that doesn't really make any sense. So we're going to see what's going on here. So let's think about powers of 2. And fill in the pattern for powers that are not negative. Okay, what does this lead you to fill in for 2 to the 0? So 2 to the 4th means that. Okay, which then, if we figured out what that equals, it's 16. So then 2 to the 3rd means that, and we know that that is 8. Okay, and then 2 to the 2nd, okay, they threw a 1 in there, which isn't necessary, means 2 times 2, which is 4. And then 2 to the 1st means 2 just 1 time, which equals 2. So what I want you to focus in on is some patterns that are occurring here. Okay, we know we are multiplying by 1 less 2 as we work down this pattern. 16, 8, 4, 2. What's happening as we work down this problem? What's happening with our answers? Hopefully you're saying they're being divided by 2 or they're being cut in half. So if we continued that pattern with 1 less 2, hopefully you saw 16 to 8 to 4 to 2. Divide that by 2 and you get 1. Okay, so 2 to the 0 equals 1. That's going to be always and forever. Anything to the 0 power equals 1. So it says if positive exponents indicate multiplying the number 1 by 2 repeatedly, then negative exponents should indicate division. Okay. All right. So if we continued that pattern, we stopped at 2 to the 0 and we got 1. We'll continue that pattern. So then what does 2 to the negative 1 equal? Divide the previous number by 2. We get 1/2. So then 2 to the negative 2, divide that 1/2 by 2, okay? Or take half of 1/2, and that gets you to 1/4. So then what is your prediction for this 2 to the negative 3? Hopefully you're seeing what's happening, and that's going to get you to 1/8. And then continue 2 to the negative 4, okay, is 1/2 4 times, which something is so wrong with my stylus tonight. Where are we? Okay, so that gets you to 1/16. Okay. So again, you're just looking for patterns of multiplication and patterns of division as we're working through these. So now it says, we want the pattern of positive integer powers to extend to 0 exponents and negative integer exponents. We can now define 0 and negative exponents as the following. So what I want you to do when you come into class next is I want you to have these 2 rules written on index cards. Okay, so this first rule, 0 exponents means b to the 0, any number to the 0 power is 1, as long as b is not equal to 0, because 0 to the 0 power is undefined. And then the other one, okay, is negative exponents, meaning any base to a negative exponent is equivalent to 1 over b to the n. Okay, so remember, the positive exponents mean multiplication and the negative exponents mean division. Okay, so we've got division going on in this problem here. Okay. So it says, which of the following is not equivalent to 5 to the negative 2? So if you sit and think about what 5 to the negative 2 is, what that is equivalent to, okay, we could come up with a couple different things. So we could say it's 1 over 5 squared, okay, which is then equal to 1 over 25. So we know we're looking for which one it's not equivalent to. And my stylus is acting funky. Okay, so, and then 1 over 25, okay, is certainly equal to 0.04. So we know that our one that it's not equivalent to is that right there. Okay, so this one I'm going to let you guys do on your own. Okay, and you can ask me what the answer is tomorrow or next time I see you guys. Okay, let's go ahead and flip the page. So we've got some more exponent laws. Okay, we talked about this in the first lesson. So when we multiply like bases, we add exponents. And this one we didn't talk about too much. We implied it because it's just a shortcut to this first one here. So when you have a power to a power, an exponent to an exponent, you can multiply those exponents. So the 2 on the front page, okay, I want you to put on an index card, the front of an index card. And these 2 back here, I would love for you to come in with those on the back of an index card. Okay? So let's sort of buzz through some of these quick examples. So this one is that, which is x to the third. This one is not an x, okay, but our base is 3, so it's 3 to the 5th. And this one's going to be x to the 6th. So then what's going to happen with this one? It's going to be x to the a minus b. Okay. So let's look at this one. So we've got 2 to the 4th divided by 2 to the 4th. So if, don't know what's happening. So 2 to the 4th divided by 2 to the 4th, if we sit and think about that division rule, means 2 to the 4th minus 4, which is 2 to the 0 power, and anything to the 0 power is equal to 1. Or hopefully some of you saw right in the beginning, anything divided by itself is equal to 1. Okay, so it's pretty cool how that works out there. So in this one, we've got, technically it's x to the negative 5, but, okay, when you have this negative exponents mean division, or think about it as where are more x's left. We are left with just a plain old 1 on top, and we're left with x to the 5th on the bottom. So these two are equivalent, one with a negative exponent, one with a positive exponent. This with the positive exponent is usually the preferred outcome. And this one would be 5 to the 6 minus 10, okay, which is 5 to the negative 4, which with a positive exponent means 1 over 5 to the 4th power. Okay? And wrapping it up, okay, consider this function. Find each of the following without your calculator. So using our exponent rules. So we're evaluating with that. So exponents come first, okay, over multiplication. So 2 to the 0 power, you hopefully know by now, is equal to 1. So 16 times 1 is 16. And what about f of 2? 16 times 2 to the 2nd, so that's going to be 4. 4 times 16 is going to be 64. And what if it's to the negative 2? 2 to the negative 2. Remember, a negative exponent means division. So this is 16 times 1 over 2 to the 2nd, or 1 divided by 2 to the 2nd. So 16 times 1/4. So in other words, what's 1/4 is 16? It's 4. Okay? You guys know what you have to come into class with. That index card with those 4 rules, 2 on the front, 2 on the back. And if you want to know the answer to that question on the front. Have a good weekend.